Hi students. In this lecture, I am going to discuss problems. Let us see first one. See the data given. A ray of light traveling in water is incident on its surface open to air. The angle of incidence is theta, which is less than critical angle. Then there will be. So asked for 3 marks in 2007 advance. Only reflected ray and no refracted ray. Only refracted ray, no reflected ray. So we have learned that whenever light ray falls on a boundary, there is reflection as well as refraction. Both will be there. And here condition is given, angle of incidence is less than critical angle. So definitely reflection as well as refraction. Both will be there. That means A and B are not correct. Now we have to decide out of these two which is correct one. So he is asking angle between them, means between reflected and refracted. Between these two rays, angle, right? Less than 180 minus 2 theta, greater than 180 minus 2 theta. So just making diagram for this, we get a clarity. So it is now traveling from denser medium. Take this as normal. Angle of incidence I, denser and rarer. Angle of refraction. This is now angle of refraction. And having here reflection, because whenever light falls on a boundary, having reflection and refraction, both will be there. Okay. Now see carefully. If there is no change in medium, if there is no change in medium, light ray is supposed to travel in the same direction like this. Okay. Now observe carefully. This is angle of reflection. This is refraction. Right? Take it as R dash here. Right. Now he's asking angle between refracted and a reflected ray, right? This angle we have to find out. This angle is how much? Then see what we can get. Here theta is given as I, right? Okay, I equal to theta. That means R equal to theta, because angle of incidence, angle of reflection, both are same. If you observe, this total angle is now 180, total value, right? But now, if you take between refracted and incident, this total angle is now less than 180, right? This is less than 180. In such a case, this value will be less than 180 minus 2 theta. Or you can think like this. This is theta. This is also theta. Okay. I will make a diagram separately. See carefully. This is instant ray. If no change in medium, supposed to continue in the same direction. Okay. This is a theta. Reflection. This also theta. So remaining angle how much? 180 minus 2 theta. Right. And if you observe a refracted ray, refracted is now like this. Okay. So this total value is now 180 minus 2 theta. Since it is now non-zero, this remaining angle will be definitely less than 180 minus 2 theta. It is just making diagram properly. We get clarity, right? So theta, theta. Remaining total value is 180 minus 2 theta. Therefore, between these two, it is definitely less than 180 minus 2 theta. Okay. So it is option C, right? It would be less than 180 minus 2 theta, right? See next one. A fish is at a depth of 1 meter in water of refractive index 4 by 3. The fish sees the water surface as a mirror except a circular patch. The radius of the patch is. So here we have to understand the meaning of the fish sees the water surface as a mirror. Mirror means light rays are reflected, right? Except a circular patch. Let us see diagram for this. Suppose this is boundary between air and water. It is now at some depth. Let us take this is normal. Okay. See, when light ray incidents, let us take here normal. This is instant ray. Suppose this is angle of incidence. And this also ion. Now consider this is equal to C. When this is equal to C, light ray will graze, right? Like this. Light ray will graze on both sides. I can take like this. It is not both sides exactly. If you observe, we can imagine a cone. Just imagine the fish is now at the vertex of the cone. We can imagine a cone, right? Or let us make a diagram separately. So here we can take many light rays from the fish. Out of them we are taking now the light rays which are making angle that is slightly greater than critical angle. This is now seen. This also seen. So you can imagine here one cone, right? Imagine one cone. So in this what happens is any light ray that is now confined to this cone, that light ray will go outside. I will make here if this is equal to C. Any light ray, for example, this is A and this is B. Any light ray in between this one, imagine one cone. Light ray, any light ray coming from the fish, it goes outside like this. It goes outside like this. But if you take beyond B, this region, the light rays will reflect like this. Reflect. Because angle of incidence is greater than C. Light rays falling like this and reflect. The meaning of water surface acts as a mirror. Mirror means light rays will reflect. So beyond this circle, if you take any point, all those light rays will reflect completely. Okay. That means any light ray that is entering this surface, means we can say the circle, those light rays will go outside. Okay. So this is the radius which we have to calculate, right? Now in this cone, in this cone, this is C, depth is H, radius equal to R. So we can write tan C equal to R by H. And we are knowing that sin C equal to mu r by mu denser, right? In this, one is air and one is water, it is mu. Sin c 1 by mu means tan c value. It is 1 upon root of mu square minus 1. Okay. So from this r value, h upon root of mu square minus 1. Now in this h value is given and mu value is given, right? I think h value is 1 and mu value, it is given 4 by 3. Substitute values here. 1 upon root of 16 by 9. 16 by 9 minus 1. That becomes now 3 upon root 7. Right? So through this cone, the fish is able to see the outer world, because for remaining all, the light rays are completely reflected. Okay. So answer is for this one. It is option A. Now see next one. A light beam is traveling from region 1 to region 4 as shown in figure. The refractive index in region 1, 2, 3 and 4 are N0, N0 by 2, N0 by 6, N0 by 8 and so on respectively. The angle of incidence theta for which the beam just misses entering region 4 is. So we have to find the value of P. See diagram for this. So entering region 1 from region 1 just misses 4. Students, see carefully the meaning of just misses region 4. Its meaning is it is touching now the boundary of 3 and 4. It is not touching here. Right? Means we can say it is grazing the surface. Just misses means grazing. Okay. So grazing means here angle of refraction is 90. I am repeating. Just misses. Its meaning light ray grazes the surface, right? You can say boundary of 3 and 4. That means in 4, refraction, angle of refraction is equal to 90. And we have learned that whenever boundaries are parallel, we can write Snell's law for any two media directly. That means here we can write for first and fourth. For these two media, we can take Snell's law directly. Let us see. This is N0 and this is N0 by 8. And so what is angle of instance? That is what we have to calculate, right? Okay. N0, N0 by 8. So you can see N0 sin theta is equal to N0 by 8. Just misses means grazing. That means angle of refraction is 90. This is 1. So N0 gets cancelled. Sin theta equal to 1 by 8 or theta equal to sin inverse 1 by 8. So just matter of one single step, right? It is a very simple one. So here we have to find sin inverse 1 by P. The value of P is, it is 8. Okay. Let us see next problem. Let's see the data given. The XY plane is the boundary between two transparent media. XY plane is the boundary. It means z-axis becomes now normal, right? Medium 1 with z greater than or equal to 0 has refractive index of root 2. So medium 1, mu value root 2. Medium 2, z less than or equal to 2. Refractive index is root 3, right? A ray of light in medium 1 is given by the vector 6 root 3 I cap plus 8 root 3 j cap minus 10 k cap is incident on the plane of separation. Find the unit vector in the direction of the refracted ray in medium 2. So this question is asked for 10 marks in 1999. Let us see how to start. So we got one clarity that xy plane is boundary. Z axis is now normal, right? Okay, medium 1, root 2, medium 2, root 3. So finding unit vector in the direction of refracted ray. Let us see. First of all, note down the given data. This is now Z axis, okay? Z axis and medium 1 given. So mu 1 root 2, mu 2 that is given as root 3, and we are given unit vector along the instant ray. Along the instant ray, take it as a cap. It is unit vector along the instant ray. That is now given 6 root 3 I cap plus 8 root 3 j cap minus 10 k cap. Okay. So we have to find b cap. What is b cap? It is unit vector along the refracted ray. Okay. Right. Let us first of all focus. What is angle of incidence? Okay. I will make a diagram once again here. See here what we are going to do. Angle of incidence, angle of refraction. This is R. Now B cap is unit vector along the refracted ray. Then we can take for these two components along the normal, along the boundary. Okay. So first we should know what is R value. And if you want to know R value, we should know what is I value. Okay. So what we can do here, normal is now along Z axis, normal. That is Z axis, K cap. Now do one thing. First find out angle of incidence. If you observe carefully, between the unit vector along the incident ray, that is A cap, between that A cap and N cap, we can see that is now angle 180 minus side, right? See, I am extending here. This is direction of A cap between this vector and N cap means normal. The C side remaining is now 180 minus side. So I am taking here dot product between these two to find that angle. See carefully, cos of 180 minus side is equal to A bar dot B bar by AB, right? So it is A cap dot N cap 0, 0. The system minus 10. Minus 10 upon minus 10 upon. See what is the modulus of this? Remember, this is not a unit vector, right? We have to divide this unit with its magnitude. That is, see how much? 100, 300, total is now 400 under root. It is 20. So this is now minus 10 by 20 means minus 1 by 2. So cos of 180 minus I is minus 1 by 2. That implies 180 minus I is equal to 120. That means I value is now 60. So we got now angle of incidence, right? Now take Snell's law to find angle of refraction. Okay, mu1, that is root 2 sin I sin 60. Mu1 sin I is equal to mu2 sin R. R value we have to find out. Sin 60 root 3 by 2, right? Let me do calculation here. Root 2 sin 60 root 3 by 2, that is equal to root 3 into sin R. Root 3 gets cancelled, and here 1 by root 2, that means R equal to 45. Okay, now to find B cap, see what we are doing. B cap equal to, it's a component along this plane, and remember along this plane a unit vector is, this is now xy plane. Okay, along this unit vector is, I can write 6 root 3 I cap plus 8 root 3 j cap upon the modulus value. See how much? Modulus value, it is 10 root 3. Let me cross check once. This is now 36, this is 64, 100, and this is 300. Root of that, it is now 10 root 3. This is now unit vector along this plane. Okay, along the xy plane, right? Next, now what we can do here, it's a component along this plane, that is B cap modulus value is 1 into cos 45 into this unit vector. Okay, that is now how much? See, that is now root 3 gets cancelled. It is 6 plus 8 by 10, 3 by 5 I cap plus 4 by 5 j cap. This is unit vector, right, in that plane. So I have taken component of B cap along this plane. Next, component of this unit vector along the normal, that is plus 1 into cos 45 into minus k cap, because k cap is upwards, right? So I can take here. So what we can take here, common cos 45, that we can take it outside, cos 45, that is 1 by root 2 cos 45. Remaining is now 3 I cap plus 4 j cap minus 5 k cap. Okay, by 5, take 5 outside. Let me cross check once. By 5, this is 1, right? By 5, okay. This is now unit vector. This is a unit vector along the refracted ray. So we have to focus carefully. First of all, finding angle of incidence. After having that, from Snell's law, we got angle of refraction. Next, we are taking components for a unit vector along the boundary, means along the boundary means plane, xy plane, and along the normal components. Okay.